Okay guys, we're going to finish up redox reactions today, and we're going to start with combustion reactions. And the thing about a combustion reaction is that it's something with carbon and hydrogen and it reacts with O2. This is important. It's got to have carbon and hydrogen, got to react with O2. Essentially, when we talk about a combustion reaction, we're talking about something that's going to burn. You're going to see flames when this occurs. So here we have methane reacting with oxygen gas, giving us CO2 and water. These are always the products in a combustion reaction. We're always going to make carbon dioxide and water. And if we've been talking about redox reactions, so let's go over the oxidation states for these elements. Now we know oxygen's in the elemental state, so that's 0. Hydrogen's always +1, so carbon is -4. All right. When we go to the products, oxygen's -2, hydrogen's +1, and carbon has to be +4. So if we look at what's going on here, we can see that nothing's happened to the hydrogen, which is fine. But the carbon has been oxidized. It's gone from -4 to +4, so it's lost electrons. And the oxygen's gone from 0 to -2. It has been reduced. Now if we jump down here, we have butane reacting with oxygen. Again, getting carbon dioxide and water, we have a balanced equation. But if we go through and do the oxidation numbers here, we get something a little bit odd for carbon. Because if we look at butane 3, 4, looks like this, all right? The carbons in butane actually are gonna have different oxidation numbers. This carbon is surrounded by 3 hydrogens, so it's gonna have an oxidation number of -3, whereas this one's gonna be -2. What is important to understand here is that carbon in butane has a negative oxidation state. If you're okay with that, then you're gonna be fine for the rest of the way. Because carbon over here has a +4 oxidation state. And what we can see is that carbon has certainly been oxidized. That's the important part here. Although we're not gonna get an exact number, it has been oxidized. And once again, oxygen has been reduced. Combustion reactions are actually pretty easy to understand because it's just the creation of carbon dioxide and water. In our reactants, we have oxygen gas and something that has carbon and hydrogen. Single displacement. This is a type of reaction that's become increasingly important as we use more and more batteries. All right, this is battery chemistry. You're going to be getting a list in class called the activity series, which is going to let us know if a reaction will actually occur. Now in a single displacement reaction, an element displaces another in a compound. So it's something in its elemental phase and it's displacing an element that is in a compound. And you can see that with these examples. So here we have solid zinc reacting with a solution of copper sulfate. All right. And when you look at the element here, which is zinc, you need to ask yourself, is that a metal or a non-metal? Now for zinc, we know that it's a metal, so it's going to replace the copper or displace the copper in the copper sulfate. And when that occurs, the copper then turns into its solid state. You've made solid copper. Zinc and sulfate, we know that zinc makes a +2 ion. So you get zinc sulfate, and we also know that's soluble if you go back to your solubility rules. Remember, copper is dissolved in water. This is already balanced, so we don't have to do anything there, but zinc and copper are in their elemental states. Here, copper is a +2 ion, and zinc is a +2 ion over here. Oxygen is always -2, which means sulfur has got to be +6. And if you notice, sulfur and oxygen don't change, so we're not going to talk about that. Zinc here goes from 0 to +2, has been oxidized, it loses electrons. Copper has been reduced, going from +2 to 0. Here, magnesium and silver nitrate. The magnesium is going to replace the silver and silver nitrate because they're both metals. So we get solid silver out of this, and we get magnesium nitrate. And it is extremely important for you to remember how to form ionic compounds, right? Magnesium's got a +2 charge over here, so its oxidation number is +2 and 0 over here. All right. If we balance this, we need 2 of those. Silver is 0 over here, it's +1 over here. Notice that nitrate isn't going to change. Nitrate stays the same, so we don't have to worry about their oxidation numbers for nitrogen and oxygen. Here, magnesium goes from 0 to +2. It's been oxidized. Silver's been reduced. Magnesium, the one magnesium, loses 2 electrons. And we have 2 silvers gaining each of those electrons. So overall, we have 2 electrons lost by magnesium, 2 electrons gained by silver. Done. All right? Now down here, copper in the solid phase plus zinc sulfate in the aqueous phase. This is an interesting one because we have no reaction here. Nothing occurs. And you're going to see that when we do a demonstration in class, because up here, zinc reacts with copper sulfate to form copper and zinc sulfate. It doesn't go from right to left. It just goes this direction. So if we put copper in a zinc sulfate solution, nothing happens, and you'll see that with the demonstration. So we have combustion and single displacement reactions.